Okay, continuing the Chapter 1 review, in this video we're going to look at numbers 6 through 8. So starting with number 6, it's finding a limit as x approaches 2 of x minus 2 divided by x squared minus 4. So first thing that we're going to try and do is plug in. We have 2 minus 2 on the top, which should be okay as long as the bottom isn't 0. 2 squared minus 4. That's not okay. 2 squared is 4, minus 4 is 0. So that's a problem. So that means we have to do something else. We're either going to have to factor or rationalize or somehow cancel things out. If we can do nothing, then this limit doesn't exist. Well, we can factor the bottom. You know this because there's an x squared, and then you can recognize the difference of squares. So when we're writing this problem, you need to make sure and write the limit first, because that's proper notation. We have not used the 2, we are only factoring, so we need to leave that in front. Make sure that you do that because you can lose points on an FRQ for that. A difference of squares, x and x, 2 and 2, one needs to be positive, one needs to be negative. So now we have the same factor in the top as in the bottom. So this becomes the limit as x approaches 2 of 1 over x plus 2. Make sure that that denominator doesn't magically float up top just because we canceled the top. Okay? So now when we plug in 2, we do not need to write the limit in this step because we are done. We are using the limit by plugging in 2. On the bottom, we have 2 plus 2, so our answer is 1/4. Okay? The next problem. When we plug in 0, we can clearly see that we're going to get 0 on the bottom, so that's an issue. We can't factor because we don't see an x squared term. However, we do have a square root. If you have a square root, you can rationalize. Rationalizing means multiplying the top and the bottom by the same thing. You write the first term, which in this case is the square root of x plus 4. You write the second term, which is in this case 2. And then you change the sign. So in the original problem, it's minus. So over here, I'm going to do plus. Then remember, we multiply the top, but we leave the groups alone in the bottom because we're going to probably cancel those out later. So the top needs to be FOILed. So that's the first, outside, inside, last 2 terms. So this is still a limit, so you need to write the limit as x approaches 0. On a multiple choice question, it doesn't matter because you don't have to show your work. On a free response question, it does matter. They will take points off. So first we have square root of x plus 4 times square root of x plus 4. That leaves x plus 4. The square root cancels out. What's inside is the same, so that stays. Remember, then we have the outside 2 plus 2 square root of x plus 4, the inside 2 minus 2 square root of x plus 4, last 2 minus 4. This will always happen that those 2 middle terms right here are identical, just with opposite signs, so they will cancel. We'll leave our groups on the bottom. One group is x, the other group is the square root of x plus 4 plus 2. So on the top, these 2 terms cancel each other out, and it becomes the limit, still the limit. We are not plugging in 0 yet, so we need to write the limit. X plus 4 minus 4 all over x times the square root of x plus 4 plus 2. Well, we can't cancel anything out yet. But we do have something we can do on the top. We have a plus 4 minus 4. Those cancel. They would give us a 0. Then, after you do that, you can cancel these 2 x's because they're the same and they are multiplied. So, finally, this becomes the limit as x approaches 0 of 1 over the square root of x plus 4 plus 2. Now we try to plug in 0. We do not have to write the limit anymore. 1 over the square root of 0 plus 4 plus 2. 1 over 2 plus 2 is 1/4, same as the last one. And that's our answer. Then, looking at number 8, number 8 says, at which values of x is f of x discontinuous? If any, name the type of discontinuity. So 2 parts. Let's find if it's discontinuous. Well, in this problem, this is a rational problem, has a top and a bottom. Whenever the bottom is equal to 0, minus 2 equal to 0, that's a problem. If we can solve this equation, we have somewhere where it is discontinuous. So we add 2 to both sides, and x equals 2. This is the value where f of x is discontinuous. They asked us at which values. In this case, we only found one value, that's fine. Where it's discontinuous, x equals 2. That is where this is discontinuous, because x cannot equal 2 if we want that equation to work. Second part of the question, name the type of discontinuity. Okay, well, in this case, if we can factor the top, we can, and cancel out the factor that's on the bottom, then it's removable. So type of discontinuity is always removable or not removable? That's the question we're asking. Well, let's see if we can factor the top. Something that multiplies to 3 and adds to 2. Well, the only 2 things that multiply to 3 are 1 and 3. And negative 2, we need a negative 3 and a positive 1. Well, none of those factors work, so this discontinuity is non-removable. So name the type of discontinuity. It is a non-removable discontinuity. And that's it for this question.